Hi, everybody. We had some problems with some recordings a minute ago. So here's the new recording. We're starting chapter 11, and we're going to be working on this for several weeks. It's on observational studies and experiments. It's like an extension of what we talked about last chapter with surveying and stuff. It's like the next progression. Some of these things you might have dealt with in science and stuff, so some of it should come back because you probably learned about it before. This second slide right here is just talking about what learning objectives we have and stuff. So, okay, next. So here's the observational study versus experiment. The main issue or difference is that one of them is just observing, the other one actually does something. The observational study is the one that has no influence on the people. So all we're doing on an observational study is watching them do what they do. So we're wanting to find out if people are doing a specific thing, what their habits are, or something like that. We just sit back and watch them and then record the information. Now, if we actually want to test something, that would be an experiment. If we're imposing some kind of treatment, making them take one or two pills of something, like if it's a medical treatment experiment, that is different than an observational study, because in an experiment we actually do something that influences the results. This distinction between the two is going to be very important as we move through this entire chapter. So make sure you know that on observational studies, we're hands off. We're not doing anything but watching what's going on. The experiment is where we actually change things, increase doses of medication, do different things like that. Next, I don't want to focus too much on this. We have lurking variables and we have this word called confounding. Basically, a lurking variable is some kind of variable, whether it's explanatory or a response, doesn't matter. But it was there all along, and it influenced the results, but then we didn't know that it was there. So like, let's say you're doing some kind of exercise experiment, and you didn't know that 50% of the people actually were going to buffets on the weekends and gaining all the weight back that they lost during the week. And you get your results and you wonder why people weren't losing any weight, but you didn't know about them going to buffets. So the buffet part would be a lurking variable, something you didn't know until you did extra research and found out that this thing was going on that was messing up your data. So that's what a lurking variable is. And then confounding, I'm not going to use this too often, but it's basically when there's two variables that are kind of connected, they have some similarities, and they kind of affect each other. And so the data can be considered confounding. Again, I'm not going to mess with these two things very often, but they might pop up here and there. All right, there's two types of variables that we're going to run into. We have explanatory variables and we have response variables. And in our textbook, the explanatory variable they call a factor. And the reason why is because, like in math, a factor is like a multiplied part of a equation. A factor of this is like a multiplied version. Anyways, and it's called a factors because these are types of variables that can be manipulated. What if one group that we're testing is taking one of this specific pill, and then another group, we change that factor, that variable, and the second group, they have two pills, and then another group has no pills. So that variable is being manipulated. It's changed. The levels in which the people are taking the pills and stuff are changing. And so that's an explanatory variable, aka a factor. So if you see the word factor, it's a thing that we're doing that we can manipulate and change to get different results. A response variable is a consistent variable across multiple different groups or different types of treatments or even different types of experiments. But it's the same in each experiment, in each group, so that you can compare it and there's nothing different. And so what you're comparing is, did every group have that same result? The explanatory one is more for big time experiments where you're testing the potency of like drugs and stuff. The response variables, like when you're testing the same thing over a wider span of people. Okay, so that'll do it for today. There's two things you need to do. One, you need to go to page 260 in the book and answer questions 1 and 2, and then post those answers on Google Classroom. And you need to, because I'm going to be gone a lot this week, to make sure you don't fall behind, you need to go to page 241 in the book and read 241 through 244. If you don't do some reading this week, you're going to fall behind. And next week, when we start moving even further, you're going to be totally lost and not do well on this test that we take eventually. So you need to do the reading. So do the reading and do questions 1 and 2. And then I'll see you guys later this week.